Welcome students. So this is our online class continuing. I hope you all have seen all the previous lectures, because if you see those lectures, then only you are going to understand this lecture. Okay? Because in previous lectures we have already discussed in detail about the charges, how they take place, and what is the value of charges at different places. So today I am going to tell you the application only. Okay? One word you can see here, this is Gauss's theorem. Okay, we have already discussed Gauss's theorem in previous lecture, and this is very important, as I have already told you. You have to remember this one. Okay, in today's topic, today we are going to find out the electric field due to a uniformly charged spherical shell. Okay, so here you can see this is one shell of radius capital R. Okay, because of this shell, now we are going to find out the electric field. So first let me explain you the diagram. Okay, so this is one shell, this is the center of shell O. From center you can see this is the radius of the shell R. Now as we have already discussed that whatever charge we apply to any conductor, that charge is distributed over its surface. Okay, so suppose we have given Q charge here. Okay, so this charge Q will be distributed over the surface of this shell. Okay, and inside the shell, what will be the amount of charge? This will be 0. Why it will be 0? That I have explained already. Okay, so you must visit previous lectures to understand it. Now let's continue here. So whatever charges we have given is distributed over the surface of this spherical shell, and inside it we are having charge Q equals to 0. Okay, now to find out the electric field, we will imagine one Gaussian surface here. Okay, now what is the total amount of electric field? Here E equals to 1 upon 4 pi epsilon naught Q upon R square, and the charge density on this spherical surface is sigma. Okay, what is linear charge density, surface charge density, and volume charge density? That also we have already discussed. Okay, so here which type of charge density will be there? Surface charge density, because it is a hollow shell, so that's why on surface only charges are there. That's why it is surface charge density, which is denoted by sigma. Okay, now let's find out the electric field at different points. Okay, so first one you can see here, it is written outside. So outside the shell, take any point P. Okay, here is one point P outside the shell. At So E equals to 1 upon 4 pi epsilon naught into Q upon R square, where small r is greater than capital R, which you can see from this diagram. Okay. Now second point, on the spherical shell. Okay. Now on the spherical shell, as we already know, the whole charge is distributed on the surface only. So we will take here capital R. Here you can see small r we have taken, but now because we are talking about the on the surface, so distance here is capital R. So E into 4 pi r square equals to Q upon epsilon naught. The whole process will be same. Okay. First we will find the value of Q, then phi E, then apply Gauss's theorem. So by following all these steps, we got this line. Directly we are writing here this one. Okay, when you are making notes, you again have to write the whole. Okay, but be very careful about capital R and small r. So E into 4 pi r square equals to Q upon epsilon naught, or E equals to Q upon 4 pi epsilon naught r square. Okay, or we can write E equals to sigma upon epsilon naught, because here I have already told you Q upon 4 pi r square equals to sigma. So here we can write sigma upon epsilon naught. Then third point, inside the shell, as I have already told you, Q equals to 0. So Q equals to 0, phi E equals to E into 4 pi r square. By Gauss's theorem, phi E equals to Q upon epsilon naught. Okay, both are the values of phi E. When we equate them and put the value of Q, the total electric field inside the shell will become 0. Okay. Now one more thing I want to tell you. Here in this equation you can see E equals to 1 upon 4 pi epsilon naught Q upon r square, where Q is constant, 4, pi and epsilon naught, they all are constant. So when we assume these all as constant and remove them, so one sign will be introduced, directly proportional one, equals to 1 upon r square. So from this equation you can see E is inversely proportional to r square. So as the distance will increase, electric field will decrease. And how much it will decrease? The square of distance. Okay. So if we increase distance twice, the electric field will decrease 4 times. Okay. If in case of r we will do 2r. Okay. Here it is a square, so it will become 4r square. So you can see here, if we increase the distance twice, it will decrease by 4 times. If you increase the distance thrice, the electric field will decrease by 9 times. Okay, equals to the square of that. Now, why we have knowing about this? Because now we have to draw one graph to show the electric field due to a spherical shell. Okay, so here you can see one graph is there. This is the value of R in x-axis and value of E in y-axis. Okay, so here as we have seen that inside the shell Q is 0, so electric field is 0. So from R equals to 0 to R equals to capital R. Okay, here from R equals to 0 to capital R, electric field is 0. Then at R it is having the highest value. Okay, on the spherical shell it is having the highest value, and as the value of R increases, the distance increases. So from this equation, as the value of R increases, the value of E decreases. So here you can see, as the value of R is increasing, the value of E is decreasing. And students, graphs are very important. In board exam, mostly in questions graphs are asked. only the graphs. Okay, the question can come like draw the graph which is showing the distribution of electric field on spherical shell. So be very careful with graphs. So I hope you all have understood this. Okay, so this is it for today's lecture. We'll see you in next lecture. Goodbye.